Welcome to the click. Let's discuss exponents rules. Again, this is part 3. Starting with the 10th rule, we have this formula, a minus b all to the power of 2k. If I change the order of the terms in this parenthesis, meaning that if I say b minus a to the power of 2k, nothing will change, and also the symbol of the parenthesis also will not change. You know why? Because guess what? My power is an even number, and we discussed this in the previous lesson. If you have a negative number in the parenthesis and your power is an even number, at that time your number will be a positive one. This time we don't have a number, this time we have a parenthesis. So, why? Let's go in details. A minus b, right? If I change the order of this, this is going to be b minus a, right? It's going to be b minus a. And if it's in a parenthesis, it is going to be minus parenthesis open, b minus a parenthesis closed. And this one right here, which is a minus, we know that when a minus comes alone, the number of it is always 1. Okay? We don't write the 1 because it's unnecessary. So right now I have this expression minus parenthesis open b minus a parenthesis closed all to the power of 2k. Right now, let's distribute this power into each parenthesis. One this and one this. So minus 1 to the power of 2k times b minus a to the power of 2k. Minus 1 to the power of 2k, because 2 is an even number, is going to be 1. And this one, because 2 is an even number, this one also will be b to the power of 2 minus a to the power of 2, which can be written as b minus 1 to the power of 2. And it also has a k, so to the power of 2k. And this is why this works. You firstly distribute the power to the different parentheses or the different numbers within the parenthesis, if there is one parenthesis. And then after distribution, you see if the power is an even number, the parenthesis or overall the symbol will be positive. But if it is a negative number, the symbol will remain negative. Let's prove the second one right now. I have a power of 2k minus 1, and I know that this is an odd number, okay? So I have, again, a minus b, right? And if I want to change the order of this, this is going to be b minus a minus, okay? And right now, I know that here we have a 1 to make it easier for you, and both of them, both the parentheses, all to the power of 2k minus 1, which is an odd number. So I am going to distribute the power minus 1 to the power of 2k minus 1 times b minus a to the power of 2k minus 1. Because my power is an odd number, right, minus 1 will stay the same. The symbol will stay minus, okay? So that is why in here, in this formula, we have a minus in here, because our power is odd. This is exactly the same to the previous rules that we learned in the previous lesson. If you have a negative number, but that number has an even power, at that time, the symbol will change into positive. But if it's a negative number with an odd power, at that time the symbol will stay the same and remain the same. That's the whole purpose of this rule. Going for the 11th rule, if the terms inside the parentheses are multiplied or divided, distribute the exponent to every factor inside the parentheses, and the answer won't change. I have, for example, x multiplied by y, or x times y, all to the power of n. this is equal to x to the power of n times y to the power of n, and the result won't change, okay? And the same with division. X divided by y all to the power of n. This is the same as x to the power of n divided by y to the power of n. Let's have an example. For example, I have 3m divided by 2y all to the power of 4. At this time, I have 4 terms inside the parentheses. 1, 2, 3, 4. So I'm going to distribute this power into each one of them. Okay? So it's going to be 3 to the power of 4 times m to the power of 4 divided by 2 to the power of 4 times y to the power of 4. The answer will be, let's just simplify them. 3 to the power of 4, 81, m to the power of 4 itself, divided by 2 to the power of 4, 16, times y to the power of 4, and this is our answer. Okay, going for the 12th rule. In division, same base, keep the base and subtract the exponents. We had this in multiplication as well, right? If we have the same bases in division this time, we are going to keep the base and subtract the exponents. So for example, I have 15 to the power of 25 divided by 15 to the power of 23. At this time, the base will stay the same and the exponents will be subtracted. 25 minus 23 is going to be 15 to the power of 2. And what if we have the same exponents this time? We keep the exponent and divide the bases. So for example, I have 15 to the power of 2 divided by 5 to the power of 2. We will divide the bases, so 15 divided by 5, and we will keep the exponent. 15 divided by 5 equals 3 to the power of 2. And let's go for the last rule for this lesson. When an exponent is negative, move the number to the other side of the fraction and make the exponent positive. We all know that any number is in a fraction. If they don't seem so, we know that they have a denominator of 1. So for example, I see this alone number, I may assume that it's alone, but actually it's in a fraction that has a denominator of 1, right? So keeping this in mind, I will have, for example, 4 to the power of minus 2. How can I change the power into a positive power? Well, I will simply write the denominator at the beginning. I know that the denominator is 1, so I will change the order and only that. And then the power will be positive. So 1 divided by 4 to the power of 2. That's it. And what if we have a number in the denominator with a power of negative? No matter, just change the order. So I have 1 divided by, for example, 7 to the power of minus 3. This is going to be 7 to the power of 3 divided by 1, or overall 7 to the power of 3. We don't need to write the denominator of 1. And if the numerator is not 1, again, no problem. We have, for example, 12 divided by 7 to the power of minus 3. It is going to be 7 to the power of 3 divided by 12 if I change the order. And this was our last rule for this lesson. I hope you got that. We are done. Thank you for being with me. Sources page.